So, good afternoon. We are going to continue the last subtopic, in the numerical method. And your chapter 9 is a PDE. The last subtopic is a Poisson equations. So we have the Poisson equation del 2u del x2 plus del 2u del y2 equal to s xy. So you notice the left hand side is exactly same with Laplace equation. It's only right hand side Laplace equation is 0, while the Poisson equation is a function of x and y, or can be a constant value. And the Poisson equation is actually describe the temperature distributions of a steady state steady state temperature distributions of a heated plate. So you have a two dimensions, where um the horizontal is putting on the x-axis from 0 to L1, and the vertical is actually putting on the y-axis from 0 y from 0 to L2, with the internal energy generation. Sorry, this is a SXY. Within the plate subject to this is a deleterious is actually means it's not a derivative boundary condition, where you have the u 0 y equal to fxy. This is x equal to 0 for all the y. For all the y, so x equal to 0 is a vertical, so it's a left boundary condition. And then the u L1y. So this is x equal to L1. So x equal to L1 is a vertical as vertical line. So this is a right boundary condition equal to gxy, where the y from 0 to L2. Ux0 equal to hxy. This is y equal to 0. Y equal to 0 is a bottom horizontal line. So this is a bottom boundary conditions. And then uxl2 equal to kxy. This one is a because we have the actually u is actually function of x and y. So this is y equal to L2. So L2 is actually at the horizontal line at y equal to L2. So this is a top boundary condition, and where the x is from 0 to L1. So Laplace and Poisson, the difference is Laplace is without energy generation as xy. So Laplace equation, right hand side is equal to 0. But Poisson equation, right hand side can be constant value or can be a function of x and y. And then on the Poisson equation, so we are going to approximate it using finite difference method at the point xi, yj. So u at the point xi, yj can be simplified at uij. So that's why you have the molecule here. The center nodes here is actually uij. And then you can see the middle vertical line. This is at xi. Right is I plus 1. Left is I minus 1. Bottom level is j minus 1. Center level is j. Top level is j plus 1. So the center molecule cell here is uij. The right cell at level j is ui plus 1j. The left cell at level j is ui minus 1j. At the center center line here, bottom cell here is ui, because standing the vertical line is all standing at the point xi. So this is ui j minus 1. The top this is ui j plus 1. Hence the Poisson equation, del 2u del x2 plus del 2u del y2 equal to s. Okay, is a function of x and y. Okay, we approximate at the point xi yj. It become, okay, del 2, okay, u xi yj del x, oh, typo, del x2. Okay, del 2 u xi yj del y2 equal to s xi yj. U xi yj can be simplified as the notation u subscript I comma j. So del 2 uij del x2 plus del 2 uij del y2 equal to s xi yj is approximate using, okay, both are using 3-point central difference. Three-point central difference. Okay, so you differentiate u respect to x. Okay, when we differentiate u respect to x, y is constant because this is a partial derivative. When you differentiate respect to x, y is constant. So means, okay, we'll fix at, okay, y at the level j because we're standing at the point xi yj. Hence, okay, del 2u del x2 using 3-point centra, you will have ui minus 1j. Okay, center point is, okay, minus 2 uij, right point ui plus 1j. Because as you learned, okay, y double prime at the point xi can be simplified as y double prime I is equal to yi minus 1 minus 2 yi plus 1 divided by h squared. This is function of one variable. This is function of two variable. Okay, u xi yj is actually simplified at uij. So when you differentiate respect to x, okay, y is constant, means we fix the differentiate respect to x, we fix the j. So that's why you have a ui minus 1j minus 2 uij plus ui plus 1j divided by delta x, which is the this is delta x, which is the h. K is actually delta t. So for delta, okay, this is y. That's why, okay, for del 2u del y2, we differentiate respect to y where the x is constant. That's why we take the vertical line. Will be, okay, 1 time uij minus 1 minus 2 uij plus 1 divided by k squared, and then equal to s xi yj. So, okay, everything is same with Laplace equation except right hand side. Now we have the s xi yj. So before we proceed, do you have any questions? Okay, if no, okay, we'll take the case, okay, when h equal to k. Then we'll multiply each term by h squared, because h equal to k. So this right hand side you have h squared s xi yj. Left hand side, okay, you eliminate the over h squared over k squared, become ui minus 1j minus 2 uij plus ui plus 1j plus uij minus 1. Okay, and then this is actually from here, and then the last three term from the second term, uij minus 1 minus 2 uij plus uij plus 1 equal to h squared s xi yj. And then we're collecting the same term. So we have here ui minus 1j, ui minus 1j, okay, and the ui minus 1j is actually left, okay, left cell here. Minus 2 uij minus 2 uij, total is minus 4 uij, okay, and then ui plus 1j is actually the right cell. Uij minus 1, this is the bottom cell. Uij plus 1 is the top cell, equal to h squared s xi yj. So okay, if you compare back to the Laplace equation, if h equal to k, the right hand side is equal to 0. Now it's only right hand side equal to h squared s xi yj. Okay, do you have any questions? If no, we look at example 1. Solve the Poisson equation del 2u del x2 plus del 2u del y2 equal to 100, where the x from 0 to 1, y from 0 to 0.5 with the boundary conditions u 0y equal to 75. Okay, since you have no questions, right? Okay, let me call somebody. Muhammad Nosarin. Muhammad Nosarin. That's why asking no question. Muhammad Alif. Muhammad Alif. So we are talking to the laptop. We see. Muhammad Daniel. Yes, okay. This one similar, exactly same with the Laplace equation, except right hand side now is 100. Okay, can you tell me u0y equal to 75? Okay, is okay. You put at where? Left, okay, boundary, right boundary, top or bottom? Which one? Okay, not clear. Left, okay, left side, right side, top or bottom boundary? Which one? Not clear. What? If you cannot speak, okay, cannot speak, you can type also. Simple question only. Left boundary, right boundary, bottom boundary, or the top boundary? Which one? u0y. That's why normally asking no question, no question. When asked, okay, cannot answer. Aini, Kalisa. Okay, so u0y equal to 75, you will put it where?
The left.
Left, correct. Thank you. u1y equal to 50, Dayang. Put at where? Dayang.
Bottom.
Bottom. Okay, this bottom is where? This is
At 1. When
x.
the
So x equal to 1. How you draw the line x equal to 1? Okay, horizontal line or vertical line when x equal to 1?
horizontal.
Yeah,
Eh,
so x
so
vertical, right? 1.
one.
So this is x 0, x. So this is the left, this is right. Okay. So please put it properly, because you put the wrong boundary will affect your inner solution there. So x0 is the left, x equal to 1 is the right. Okay, and then ux0 equal to 0. Okay, Eliza. Eliza also sleeping, I think. Afternoon nice to sleep. Morning also sleep, afternoon also sleep. Indrazit. Okay, Eliza, you want to answer? ux0 equal to 0, is it? Okay, or left is the first one. Okay, second one is the right boundary. So ux0, you put at where? Okay, now just left, top and bottom at where? Not clear. Can you speak loudly? I cannot hear. Can you speak loudly? Where? Okay, or you please type it. Bottom, correct. Yes. So bottom, this is y0. Y0 is here. So y0 is bottom. So the last one is y equal to 0.5 is top, y equal to 0.5. So x0 with left, okay, left boundary, x1 is the right boundary. And then by using finite difference method with h equal to k equal to, okay, 0.25. Okay, and then you may, okay, go to draw the grids here. So x from 0, increment 0.25, okay, and then, okay, up to 1, y from 0, okay, increment is 0.25. So, okay, then you put up the, okay, u0y equal to 75 here. So left is equal to 75. u1y equal to 50. When x equal to 1, u equal to 50. ux0 equal to 0. Okay, mean when y is 0, u is 0. So you may say, okay, corner point is contradict, so you may add up. So, okay, 75 you may add with 0 and then divide by 2. So 50 also, because it contradict with, okay, 0 here. Mean left boundary, okay, right boundary said 50, bottom boundary said 0. So you add up 50 plus 0, divide by 2. Okay, after that, okay, okay, x 0.5 mean when y equal to 0.5, u is 100. So these two cells also, okay, this corner point also contradict. So you may add up 50 plus 100 divide by 2. Mean 50 plus 100 divide by 2. So this cake point also, okay, this corner point also contradict because left boundary said it is 75, top boundary said it is 100. So you can use 75 plus 100 and then divide by 2. Okay, then after fill in the boundary condition, this example you just, okay, need to solve u11, u21, u31, three unknown. Then you have, okay, have three, okay, linear equation. So to get the linear equations, okay, applies okay, your 5-point formula for the Poisson equation. You have your top cell, okay, the coefficient is 1, center is -4, left is 1, right side is 1 equal to h squared. Okay, the you have here, this is a s xy, h squared time 100, and then bottom is 1. Okay, so first time you, okay, the first equation, the center will be at u11. Okay, from u11, this is left, okay, this is right, this is bottom. And then don't forget equal to h squared times the function of 100. So that's why, okay, all the right hand side you have a h squared. H is 0.25 squared times the, okay, function is actually here 100, so times 100. All clear. So you have top, okay, 100, left 75, center -4 u11, bottom plus 0. Okay, right hand side, right cell plus u21 equal to h squared 0.25 squared times the function at the right hand side, which is 100. So this is the first equation. And then you simplify the first equation. We have -4 u11 plus u21. So equal to 0.25 squared times 100. Okay, and okay, left side total is 100. So, okay, 75 you bring collect to right hand side. So you get -168.75. In here, okay, 0.25 squared times 100. Left side, okay, the boundary condition 100 plus 75 bring to right hand side. So minus 175. So you get negative 168.75. Yeah. So you put into the matrix form. This is U11, the second column U21. This is U31. So negative 4 U11 plus 1 times U21. Okay, we don't have U31, so it's 0, equal to negative 168.75. Okay, later on, we move the molecule here, one column to the right hand side. Okay, right hand side. So erase it. Okay. And the second time, we'll target. Okay, second round, you will target at, okay, center is U21. So you have top 100, left is 1 time U11, center minus 4 U21. Okay, right is 1 time U31, okay, plus 0, equal to h squared times the function here. This is a sxy times 100. Simplify it. You got, okay, negative 4 U21. Okay, start from here. You have a U11 minus 4 U21 plus U31 equal to 0.25 squared times 100 minus 100. And here, this one, left side. So now it's minus 100. Because right hand side, same k value, 0.25 squared times 100. Okay, left hand side, the boundary is actually total is 100. Bring to right hand side, so minus 100. You get negative 93.75. Yeah. So we put into the matrix form. U11 is 1 time. Okay, U21 is negative 4, U31 is 1, equal to negative 93.75. Okay, after that, okay, to get the third equation, okay, we'll move this molecule one column to the right. So now center will be at U31. Center now is U31. So okay, top, okay, 1 time times 100, left, okay, U21 1 time, center minus 4 U31. Okay, bottom, okay, 1 times 0, right is 50, equal to 0.25 squared times 100. Okay, and then simplify it, you have U21 minus U41, okay, equal to 0.25 squared times 100. Okay, left side is total is a 150, so bring to right hand side, become minus 150. So now is minus 150. You get negative 143.75. Yeah, the third. So the third equation you put into the third row of the matrix form here. Okay, U21 1. So mean U11 is 0. So negative 4 U31 equal to negative 143.75. Okay, you can quickly obtain this linear system using your scientific calculator using equation modes. Okay, so simultaneous equation, 3 unknowns. Key in your linear system equation by equation, the coefficient equation by equations. So you have negative 4, 1, 0, negative 168.75, and then 1, negative 4, 1, okay, negative 93.75, and then the last one, 0, 1, negative 4, negative 143.75. Okay, check before you press equal. Okay, the vector B, negative 168.75, negative 93.75, negative 143.75. Okay, the third column of vector A is 0, 1, negative 4, correct? Second column of the matrix A, 1, negative 4, 1. Okay, The first column of matrix A, negative 4, 1, 0. Okay. Once correct, okay, press equal, you'll get U11 is 54.4643. Okay. All right. Up. Okay. U21 is 49.1071. Sec. U31 is 48.2143. Okay, and then you may fill in. Okay, oh dear, forgot to edit the value here. And then you may fill in if you get I think the PDF, okay, there is a careless mistake, so this is a correct version. So you fill in the value that we obtained, okay, just now in here. 48.2143, 49.1071, okay, 54.4643. Okay, the previous PDF, there's a careless mistake because I forgot to multiply with the h squared. So please correct it. Correct it, okay, the right hand side here, and the vector B and the solution. So do you have any questions? Okay, I think this is a Poisson example 1. Okay, we'll put up. Okay, we are going to show you how we can quickly solve the Poisson equation in Microsoft Excel using the iterative calculation. So first of all, we draw the grid scale x from 0, increment is 0.25, okay, up to 1, and then y from 0, 0.25 up to 0.5. Fill in the left boundary condition u0y equal to 75. Let me fill in 75 here. u1y equal to 50, so mean the right boundary when x equal to 0 for all the y is equal to 50. Oh, should be here. X1 is here, equal to 50. And then ux0 equal to 0 is y, when y equal to 0, for all the value of x, u is 0. So you can put it equal 0. So this cell is contradict, okay? So the contradict one, you can have, 50. 50 is from right boundary, 0 is from, bottom boundary. So you may add up 50 plus 0, divide by 2. Okay, this corner point also contradict. From the left boundary set is 75, from the bottom boundary set is 0. Then you may add up, divide by 2. Okay, ux 0.5 equal to 100 means when y equal to 0.5 for all the x, u is 100. So you can put it 100 equal 100. So when you copy it, is always equal 100. Okay, hence the right corner point contradict, from right boundary set 50, but from the top boundary set 100. Then you may add up 50 plus 100, then divide 2 to average them. Okay, the left corner point also contradict because from left boundary set 75, from the top boundary set 100, then you add up 75 with 100 and then divide by 2. Okay, of course, if you don't average it, it also won't affect your solution, because your u11, your top is 100, left is 75. You will never touch up the corner point. Okay, when you want to solve u11, for example, here, this is your u11. Okay, you will never use the corner point. So when you want to solve, let's say u31, I use here u31, apply that 5-point molecule, you see you will never touch that corner point also. Okay, then, so now, after fill in the boundary, you have only three values, which is u11, u21, u31 to be solved. So we have three simultaneous equations as you form it here. Then using the equation, solve it using the technique that you learned in chapter 3, or you may directly use your scientific calculator. If you have a three simultaneous linear equation or four simultaneous linear equation, then you may directly using your calculator. Okay, and in Microsoft Excel, we are going to show you how we can quickly solve U11, U21, U31 without forming the system of linear equation. Okay, so look back this 5-point form molecule here. This 5-point molecule, it says 1 time of the top cell plus 1 time of your left cell minus 4 time of the target that you want to solve plus 1 time of the right cell plus 1 time of bottom cell equal to h squared s xi yj. Okay, where the h squared here is 0.25 squared. The function s xi yj is 100. So mean when you apply this thing, first time, when you apply the molecule first time, where you target at the U11, at center. So you have top 1 time, left 1 time, minus 4 time U11 plus right cell plus bottom cell equal to 0.25 power 2, means squared times 100. We want to solve for U11. Hence, U11 will be top plus left plus right plus bottom minus is 0.25 squared times 100 divided by 4. Hence, we are going to key in this formula in the cell U11. Okay, we are going to key in here top 1 time, left 1, right. Okay, you will key in D16. D16, your right is E16. E16. Bottom is D17 minus 0.25 squared time 100 divide 4. Check back. Standing actually D16. So left is C16, right is E16, top is D15, bottom is D17 minus h squared times the function s xy, which is 100. Make sure bracket divide by 4. You may round it, to compare with the solution using manual, where we perform the calculation using 4 decimal place. After that, you can go to options, formulas, make sure enable iterative calculation. If you're not enable, then they will give you error. If you're not enable when you copy it, I think because I will I enable it? Suppose because previously I enable it. If not, it will give you there's a I think circular reference. So to solve it quickly, you have to go to the options, formulas, and then enable iterative calculation, and then OK. Then you obtain the solution quickly without forming the linear system. You can check the solution. 54.4642, 49.1071, 48.2143. So quickly, compared to if you solve manually, you have to apply the molecule one by one to get that three linear equation, simplify it, put it to matrix form, and then if you're not using calculator, then you need to use technique in chapter 3. So do you have any questions here? No. Why no question?
No, don't.
Okay, if no, we can proceed, I think, to the second example. Okay, the same thing. Solve the Poisson equation del 2u del x2 plus del 2u del y2 equal to xy. So now the right hand side is the function x times y, where the x from 0 to 1, y from 0 to 1, with the boundary condition u0y equal to 1, u1y equal to exponent y, ux0 equal to 1, ux0 equal to exponent x, where the x from 0 to 1, by using finite difference method with h equal to k equal to k 1/3. Okay, we form it using Microsoft Excel. Okay, I think. Maybe this one. Okay, delete everything. Okay, u0. Okay, x from 0 to 1, increment is 1/3. Increment is 1/3. Y also 0 to 1, increment is 1/3. So u0y equal to 1. Okay, calling who? It's Indrazit. Indrazit, are you around? Indrazit. Lim. Lim Yuchi. Lim, okay, are you around? Also not around. Muhammad Abdirazak. Muhammad Abdirazak. Muhammad Saro Ikwan. Muhammad Nosarin. Muhammad Alif. Muhammad Haziq Aiman. Muhammad Saswan. Muhammad Taufik. Muhammad Zahiruddin. Zahiruddin. Who is sitting in front? Please answer me. U0y equal to 1. Put it at where? Navid. Chris, okay? Nobody sitting in front.
Left.
Okay, left, correct. U0y equal to 1 is left. Ux0 equal to 1. Okay, okay, Zijian, thank you. Okay, left and then bottom, yes. So this case is not contradict. It's actually same condition in the Laplace equation. It's only the difference we have now. This is the right hand side is not 0. Okay, u1y equal to exponent y. Okay, Ng Jiayi. U1y equal to exponent y. Left, okay, now where? Left, right or top? U1y.
Uh,
U1y. This is x equal to 1. Right or top? Right, okay, correct. X equal to 1 is right hand side. So it's equal to exponent y. Exp, y is here. And here also overlap, okay. So okay, this example there's no contradict. All the boundary are overlap. All the corner point are overlap. So the last one, ux1 is y equal to 1. Okay, u is exponent x. So exp exponent, this is x. Okay, you see, overlap here, also overlap. Okay, this case, okay, there's no contradict at the corner point. Okay, then you need to solve u11, u21, u31, sorry, 31, u12, because level 2, this is u22. Okay. Then there's how you have here. Okay, that's how you got, okay, u11, u21, u12, u22. Okay, and then you may apply, okay, that 5-point molecule, okay, one by one, before we see, okay, to quickly solve it using Microsoft Excel. Yeah. Okay. This is the value already. Previous one. Okay, the first equation, okay, is actually, you can see u11, u21. Mean I solve, okay. My first equation is actually from u1, where I target center is u11. Because you see the first unknown to solve is u11. The second one is u21. The third is u12. The fourth is u22. If you arrange it differently, doesn't matter. Because, okay, you can swap, okay, any row of your linear system. So you, okay, mean the first equation here, we, okay, target the center as u11. So top, this is left, this is right, this is bottom. Okay, so the first equation, you have top 1 time u12 plus left is 1, center minus 4 u11, right is u21 plus the bottom 1. Okay, remember, it's actually when you solve this one, you have actually when the molecule, you have 1, and then center minus 4, left is 1, right is 1, bottom is 1, equal to h squared time, okay, your s xi yj. H is 1/3, so h squared is 1/9. So s xi yj. So mean here, mean is xi, okay, yj. So when you're okay, this one s xi yj is actually, you are standing, okay, center is u11. So, okay, the xi is 1/3. Yj mean from where you standing center, x is 1/3, y is 1/3. So 1/3, 1/3. Okay, is it clear? S X I Y J. X I Y J is actually center. Okay, we are standing at the point X I Y J, mean from the center. We move down to check where's the x value, 1/3. From the center here, u11, your y value is 1/3. That's why you hear 1/9 is a h squared. So h squared, this is a x value 1/3, y value 1/3. Okay, and for the first equation, okay, if you put into the metric form, you will have, okay, you may guide here, label the column to guide you to key in the coefficient u11, u21, u12, u22. So you see u12, yeah, u12 here, 1. Okay, minus 4 u11, u21, u21 here. Because, okay, is, okay, u12 is actually here, u12 minus 4 u11 u21. Okay, and here let 1 you collect to right hand side. Yeah. So more, so you have here exactly 1/9. Okay, may alpha x alpha y, and then minus the left hand side coefficient, let's say I put a, and then calculate. X is 1/3, 1 divide 3, y is 1 divide 3. A is actually the left hand side coefficient, 1 plus 1 total is 2. So mean A is 2. So you get here negative 1.9877, the B1, the vector B1 here. After that, move the molecule one column to right hand side. So where the center will be at U21. So mean you have U22 1 time U11 1 time. Center -4 U21. Bottom is 1. Left right cell is 1.3956. Then here these two value bring to right hand side. Then you can calculate again. For the second time, the center is U21, so the x is actually 2/3 here. X standing here. From where you stand, the center point is where the x and y there refer. So the x is 2/3, the y still 1/3 here. So x 2/3, y 1/3. So if you have any question or not for the xy value there. So x now is actually 2 divide 3. Y still 1/3. You may press down. A is actually 1.3956 plus 1 because minus a. So it's actually a 2.3956. So you get negative 2.3709. Yeah. And then you put up U22. This is U22 one time. U11 here one time. -4 U21 here. So U12 is 0. Second up. So now we need to solve U12, U22. Hence to solve U12, you need to target the center is at U12. So you have top left, this center, this bottom, this is right. Then mean you need to I'm going to erase everything. You got two equations. The third equation you want to solve for U12. You have to make the U12 as center. This will be center. So the -4 U12. Top is 1.3956. Left is 1. Right cell is U22. Bottom is U11. And then when you are target at U12, x is 1/3, y is 2/3. X 1/3, y 2/3. Because U12 is actually the center. So you move down, x 1/3 to left, y is 2/3. And then you may collect here this thing. So you get the same coefficient because left side the value is 1.3956 plus 1, same with the second equation. The right hand side the product 1/9 1/3 times 2/3 same. That's why the B3 vector B the third value same value. And then you have here -4 U12 here -4 U22 one time U11 one time. So U20 is U21 is 0. So the last equation you have to target the center at U22. So I erase it. The last equation, this one is center, so the okay, bottom x is 2/3. Okay, y also 2/3. So the fourth equation, top 1.9478, left 1 u12, center -4 u22, right is 1.9478. Okay, bottom is u21 equal to 1. Okay, h squared is 1/3. Okay, so we are standing at u22 where the x is actually 2/3, y is also 2/3. Okay, and then you may calculate the vector b number 4. Mean 1.9478, 1.9478. Okay, you bring to right hand side is actually minus 2 times 1.9478 because 2 times. So you calculate. Okay, x, okay, 2/3 correct. Y 2/3, so 2 divide 3. Okay, a is actually 1.9478 times 2. So you get negative 3.8462. Okay, the vector b4, negative 3.8462. So u12, okay, u12 is here, 1 time. UK22 is negative 4 time. U21, U21 1 time. So U11 is 0. Okay, and you can quickly obtain the solution of U11, U21, U12, U22 using the scientific calculator of the model, okay, 570EX Classic. So you may go to the menu. Okay, simultaneous equation for unknowns. Okay, key in the coefficient k of the linear equation one by one. So you have negative 4, 1, 1, 0, negative 1.9877. Then second equation is 1, negative 4, 0, 1. Okay, negative 2.3709. Okay, the third equation is 1, 0, negative 4, 1, and then negative 2.3709. Okay, key in where? Yeah. Okay, the third equation, check back. 1, 0, negative 4. Oh, this is 1. Okay, and then negative 2.3709. Okay, the last equation, 0, 1, 1, negative 4, negative 3.8462. Okay, check it before you press equal. So the vector b, negative 1.9877, negative 2.3709, negative 3.709, negative 3.8462. Okay, the fourth column of matrix A, 0, 1, 1, negative 4. The third column, 1, 0, negative 4, 1. The second column, 1, negative 4, 0, 1. First column, negative 4, 1, 1, 0. Okay, correct. Press equal. So x, which is tally with u11, is 1.1352. Y is actually u21 because it arranged here. So x, y, okay. Y is a u21 is 1.2765. Z is actually tally with u12 is 1.2765. Okay, T is actually tally with u22 is 1.5998. Okay, this is solving it manually. Okay, do you have any question before we see how to solve using Microsoft Excel? Because now you have the function of x and y, we have some tricks there. Okay, any question or not?
Oh, Doctor, proceed.
Okay, okay, and then okay, this is the Poisson example 2. Okay, so we want to solve u11, u21, u12, u22. Okay, and then we have the right hand side exactly equal to um, okay, 1 time top plus 1 time left minus 4 time let's say we target at u11, so minus u11. Okay, first of all, let's say I'm going to we want to key in the formula in u11 first. Okay, so okay, u12 we refer at top, this one is left, so minus 4 times u11 plus right cell plus bottom cell. Okay, if Laplace, it is equal to 0, but if this is the Poisson equation, this one is equal to h squared, which is 1 over 9, and then your function is actually xy. Okay, 1 over 9, oh, look like you divide, multiply xy. Hence, case solving for u11 will be top plus left plus right plus bottom minus 1 over 9 xy. So minus or xy divided by 9. And then, okay, the big bracket, okay, divide by 4. Okay. Then, so you key in the cell u11, or you want to key in at u12 also doesn't matter, because top, left, right, bottom, these are general. Okay, let's say if we key in on the top also can. Okay, if I key in on the top, okay, like this. Okay, let's say I key in at u12. So if I key in at u12, this one I just change. This is u12. This is u12. Okay, so I key in here. Big bracket. Okay, we are standing at D16. D16. So top will be D15. Bottom is here, D17. Left, sometimes you cannot. Okay, just now D16. So left is C16. Right is E16. Because we are standing at D16. We are standing at D16. Put it here. Because if you confused to see, first. I drop to see. Okay, this one is, if this cell is D16, because here D16, then this will be C16, CD, this is E16, this is D15, D17. Then, okay, at the cell D16, you key in your formula D15 plus C16 plus E16 plus D17 minus, okay, x times y. Okay, here you see. Okay, minus, okay, x. Okay, from where you, okay, standing column D, x is 1/3, multiply, okay, y is 2/3 here. Then you divide by 9. Okay, outside of the big bracket, divide by 4. They give you not value because here. Okay, and I will show you later on when you copy it, you will see, okay, what is the problem. Okay, when I copied, don't put the yellow color. You cannot see where is the cell. Okay, you see when you copied, what is the problem there? We are now at the where? E16. Okay, the problem is actually later we create by the xy. Okay, x now, E19, x correct, y C16. Do you see that the y is moving? Okay, y's value suppose is a B16. Okay, what is the problem here?
It moves.
Move, okay, because when you key in the formula at here, your y is actually B16. You see, I key in for you to see. And then later we got some trick to solve that. Okay, x is actually, we are standing here, x is a D19. So you minus D19. Okay, x D19. Y is actually B16. B16. Divide 9. Close. Divide 4. Okay, x is actually, when you copy it, x D19. Okay, this one close. So x correct, move. Because when you copy it to the next column, D19 will become E19 correct, but B16, B16, it becomes C16. You see, x correct, y value move to C16, which is wrong. We want y, when we copy to the next column, y maintain and column B. Maintain at column B. Okay, so what you need to do, for y variable, you need to put up, you fix the column is actually a dollar in front of column B. Okay, now you see. Then I may put up to round it 4 decimal place. Okay, so now you see. You see now my y maintain at B16. B16. So mean what you need to do, okay, for y variable, you need to fix column. I put out here. Mean y variable need to fix column. To fix column, there's a dollar in front of the column label. Okay, later on, so you see, okay, so when we fix column, so when we copy the formula, okay, we copy the formula y maintain, okay, y maintain column B. That's correct. Okay, how about now, if we copy it down, what happened? Okay, this one erase first. Okay, we copy it down, you see, when we copy it down, close first. Then you click one of the cell and see. X move down. So when we copy it down, okay, we copy it down, D19, which represent the X, will become D20. That's what you happen here, D20. So mean X variable, you need to fix row. So that's why it's actually, we want X maintain. Okay, this is actually D19. That's why XK you need to, this one I have to close. To solve this one, okay, X variable need to fix row. Okay, how to fix row? Before the row label or after the column there, you put dollar there. Okay, I put it properly, big for you to see. So initial formula, X D19. Initially X is D19. X D19, Y is B16, mean X times Y. Okay, X variable fixed column. So dollar at the back. Yeah, so close. Yeah. Okay, dollar at the back, okay, or in front of the row, okay, label. So mean this is fixed row. This one is fixed row. Okay, dollar in front of the column. This is fixed column. So if you have like this means fixed column, fixed row. So mean it's a constant value. Okay, you put dollar front at back, so mean you fix the column D, fix the row 19. So you always take from the cell D19. So this is always we use for a constant value. And then you use a fixed column, I think, for the RK4, okay, RK4 techniques that you solve for the first order differential equation. Okay, and then fixed row here, okay, because okay, if you not fixed row, when you copy it down, the X will move down. Okay, if you not fixed column, Y, when you copy the next column, Y will run, okay, to the left boundary. X, if you're not fixed, okay, it will run down. It's not X value anymore. Okay, that's why you need to, okay, edit here X dollar at the back. See, yeah? D19 is actually the X value 1/3. So you see a dollar at the, okay, in front of 19. Okay, dollar B16, dollar in front of B means fixed column B. That is a Y value. Okay, so now if you copy it to the next column because the same row, so X, okay, no problem. Okay, X, okay, we move to next column, and okay, you see Y correct, X correct. Huh? Now, okay, select 2, you copy it down. Okay, let's see. So X correct, Y value correct. Okay, U 2 1. So X, okay, Y value correct, X value correct. Okay, and then we may check with the manual. Okay, this 4 value. So the first value, okay, U11 1.1351. Manual is 1.1352. Okay, the second value U21 1.2764. Okay, manual is 1.2765. Okay, the Excel, okay, U12 is 1.2763. Manual is 1.2765. Okay, the last value U22, this is 1.5. Excel 1.5997. Manual is 1.5998. Okay, here sometimes the iterative calculation, you may press what? I think Shift 9. Okay, see. File, options, formula, enable. No. Sometimes last time is with pressing F9 it will converge. Here no need. It's already stable converge. So this is case solving using Microsoft Excel by enable the iterative calculations.